When is a pixel not a pixel? Pixels, points, and display-independent pixels. I never understood why in web design we would set the artboards to be a pixel size that was significantly different than the actual number of pixels on the device's screen. And this post here will try to explain a little bit why. And it has to do with the fact that we now have high resolution displays where a pixel is really no longer a pixel. And so it's confusing because there are at least, you could think of three main pixels you might be doing if you're doing user interface design these days for digital screens. You might be working on the web, and so you're using CSS or something called probably web pixels. You might be working on iOS, and in iOS you would be using something called points or PTS. And then if you're on Android, you're going to be using something called density-independent pixels, DPS. And the reason that it's confusing is that although web pixels, points, and dips are pretty much all the same, roughly speaking, none of these are actually your traditional screen resolution pixels. These three units all assume that you're rendering the output on a device that is not high resolution, meaning you're using a device where 1 pixel used to mean 1 pixel. And so that benchmark is set at a resolution of approximately 160 pixels per inch. And so when you design on the web, iOS, or Android, you're essentially using that old non-HD screen display of 160 pixels per inch approximately as your baseline. And so this is why it's confusing, is because when you actually look at the device that's being rendered on, you might be looking at something with 1,000 or 2,000 pixels across. But what's happening, of course, is the device is automatically using multiple hardware pixels to display one of those web pixels or points or display density independent pixels. So how did this come about? Well, if you look into the history of pixels, and we're just going to start around, late 2000s, 2008, 9, 10, because pixels actually are confusing the further you go back. But, in 2008, if you had one pixel, which was 1 pixel by pixel, a single black square, it was very straightforward. That was 1 pixel large, and life was easy. But then in 2010, Apple introduced the Retina display. And so what happened was the iPhone 4 with Retina display took the screen size and was able to pack in 640 by 960 pixels into the same screen that previously only held 320 by 480 pixels on the iPhone 3. And so this means that the pixels per inch, the PPI, doubled from 163 PPI to 326 PPI. And so in order to accommodate the high screen resolution and avoid driving designers and developers crazy by having their work appear on different sizes on different screen resolutions, Apple introduced something called logical resolution. And what logical resolution essentially is pegging a device's resolution to the old 163 pixel per inch screen, so the before the Retina screen. And Apple used the term point to describe a measurement that is on logical resolution. And so this means that if you have a line that is 163 points long, if you were displaying that on a screen with 163 pixels per inch, a resolution of that line would then be essentially 1 inch. But the same 163 point line on a high resolution display, let's say you have a display of 326 pixels per inch, would use twice the number of screen resolution pixels, but it would remain the same actual length in practice because you specified it using points. And so to summarize, Apple's using a concept called logical resolution to define something in points. And so if you're designing in software like Sketch or Figma or some sort of user interface software for the iOS, you'll be working in points. And what this means is that the iPhone XS has a screen resolution of 1,125 by 2,436 pixels, but it has a logical resolution of 375 by 812 points. And so if you're thinking in points, you're doing just fine. Now, what about Android? Well, instead of using the term points, Google essentially developed their own term called density-independent pixels. And it's really what the term says. A density-independent pixel is the size of an element in pixels on a screen that is independent of the actual screen resolution's pixel density. And so Android uses 160 ppi as their default screen resolution, 3 pixels different than Apple. And so, therefore, on Android, a line that is 1.5 inches wide when placed on a screen with a density of 160 pixels will occupy a total of 240 pixels on the display. And the line is also 240 dps. But if that 1.5 inch line was placed on a screen with a density of 320 pixels, it would occupy a total of 480 pixels on the display, but the line would still remain 240 dp, or dips. I think it's dips pronunciation. But I have to check. In Android, they also use the term scalable pixels, which is essentially the term for fonts instead. And so what about the web? Well, the web uses a term called pixels as well, or web pixels, and it's pretty much the same as points and density-independent pixels. They sometimes might refer to a CSS reference pixels or CSS viewport pixels or CSS pixels. And from what I can tell, they all mean the same thing. And so, in short, a pixel, a dip, and a point could all mean the same thing if you're thinking in terms of web, iOS, and Android development. But this pixel is very different than your native screen resolution pixel, which is the actual density of hardware pixels crammed into that display. And so this is why it's confusing. And if you're interested, there's some other posts regarding pixels, XY dimensions, and trying to understand why mobile phones actually display the resolution first in vertical and then in horizontal units, which is a bit weird to me.